1994, Dodge bolts a fuel pump to a diesel engine capable of producing 700 horsepower at the wheels. Then they turned it down. They turned it down. On purpose. And the way they did it was so simple that 30 years later you can undo it in your driveway with a dial indicator and a wrench. No laptop, no tune, no software subscription. Just a mechanical adjustment that takes about 2 hours and hands you 30 to 40 horsepower you already paid for. The EPA made them bury it. Here is how to dig it up. The engine is the 5.9L 12-valve Cummins. If you know diesel, you already know this engine. If you don't, the short version is this. Cummins built it for agricultural equipment in the 1980s. Dodge put it in the Ram starting in 1989, and it turned out to be one of the over-engineered truck engines ever bolted to an American pickup. The block is cast iron. The head bolts are 12 millimeters in diameter with 6 per cylinder. Cummins engineers tested the stock head hardware to 100 pounds per square inch of boost before it stretched. The thing was built like a piece of industrial equipment because it was industrial equipment. The fuel system is mechanical. That matters. The Bosch P7100 injection pump, also called the P-pump or inline pump, uses 6 individual plunger and barrel assemblies to deliver fuel to each cylinder. There is no ECM controlling it, no common rail pressure sensor, no electronic fuel management of any kind. A mechanical pump driven by the camshaft, metering fuel the way diesel pumps have worked since the 1940s. That mechanical design is the reason this trick works, and the reason Bosch had to bury it. When Bosch set up the P-pump for the 12-valve application, they had a list of requirements: emissions compliance, noise and vibration targets, cold start reliability down to -40 degrees, drivability across a wide range of altitudes and conditions. The factory timing setting they landed on was approximately 12 degrees before top dead center. 12 degrees. That number is not where the engine makes its best power. It is not where it makes its best fuel economy. It is where Bosch could guarantee compliance with EPA regulations, a quiet combustion event, and a truck that would start reliably in a Minnesota winter without needing to be plugged in. Those are legitimate concerns, but they come at a cost. Injection timing controls when fuel ignites relative to the piston's position. Too early, and you get knock, heat, and mechanical stress. Too late, and you lose efficiency and power. The sweet spot for a street-driven 12-valve, according to every reputable P-pump builder who has ever published a dyno sheet, is somewhere between 17 and 21 degrees before top dead center. At 18 degrees on a stock truck with stock injectors, stock turbo, and stock everything else, you are looking at 30 to 40 horsepower over what the factory set. Driving Line, Diesel World, and 4BT engines all publish consistent numbers from independent dyno testing, 30 horsepower minimum. Some trucks see more, depending on condition and supporting mods. That's the difference between a 200 horsepower truck and a 240 horsepower truck on an engine that already cost you $40,000 and never asked for anything but clean fuel and fresh oil. Here's why advancing the timing works. When diesel fuel does not explode the way gasoline does, it ignites from compression heat and then burns progressively as the piston travels down the cylinder. The timing of that ignition event determines how much of the burn happens while the piston is still near the top of its stroke, where it can transfer the most force to the crankshaft. At 12 degrees, the factory setting, a significant portion of the combustion event happens later in the piston's downstroke. The engine is already past its optimal power transfer window before the fuel is finished burning. You get the heat, you get the exhaust gas, you do not get all the mechanical work. Move the timing to 18 degrees, and the combustion event begins earlier. More of the burn happens at or near top dead center. The piston absorbs more of that energy. The crankshaft sees more torque. The rear wheels see more horsepower.
the exhaust temperature actually drops slightly because the engine is converting more of the combustion energy into mechanical work rather than dumping it out the tailpipe as heat. That last part is not a side note. Lower exhaust gas temperature at higher power output is the signature of good timing. It means the engine is working more efficiently, not harder. A properly timed 12-valve runs cooler under load than a factory-timed one making the same power. That is the physics. Bosch knew it in 1994. The EPA is why they ignored it. The adjustment itself is mechanical and direct. There is no software involved because there is no software to involve. The P-pump is a physical device connected to the camshaft by a gear. Rotating the pump relative to that gear changes when fuel is injected relative to piston position. That is it. You remove the number 1 delivery valve, the fitting at the top of the pump that connects to the number 1 cylinder's injector line. A dial indicator goes into the opening. You rotate the engine by hand until the indicator reads the cam lobe height specified for your timing target. The pump nut comes loose. The pump rotates on its mounting. Tighten the nut, remove the indicator, reinstall the delivery valve. Start the truck. The process requires a dial indicator, a delivery valve socket, and enough mechanical comfort to work around a running fuel system. A good shop can do this in under 2 hours. A careful home mechanic with the right tools takes an afternoon. The parts cost nothing because you are not changing any parts. What matters is where you stop. The stock head gasket and retorqued factory head bolts will handle 16 degrees without complaint. Diesel World has published accounts of trucks running 15 to 16 degrees on stock hardware for years without lifting a head. Past 16, and you are asking the factory head gasket to manage cylinder pressures it was not designed to contain. At 18 degrees on a stock truck, the recommendation across every P-pump forum and publication is to retorque the factory head bolts before you advance. Pulling the torque down on 12mm head hardware and bringing it back up to spec costs nothing and adds a meaningful margin of safety. With ARP 625 head studs in a fire-ringed head gasket, the ceiling moves considerably. Diesel World has documented trucks running 30 degrees with the right bottom end support. Competition sled pull engines have been documented at 40 degrees and beyond on purpose-built bottom ends. But for a street truck, 18 to 21 degrees on good head hardware is where the 30 to 40 horsepower lives without asking for trouble. Here is the part that deserves attention. Bosch set the P7100 to 12 degrees in compliance with EPA emission standards for the 1994 model year. Advancing timing increases NOx emissions, the specific compound the EPA was targeting in the 1990s clean air push. A truck at 18 degrees produces more nitrogen oxides than a truck at 12 degrees. That is true and worth acknowledging. What is also true is that the EPA's solution was to take 30 to 40 horsepower out of every 12-valve Cummins that left the factory and handed to the regulations instead of the owner. Every single P-pumped 12-valve Cummins that left the factory. The owners paid for the engine, they paid for the pump, they paid for the capacity. The EPA decided they could not have the output. The mechanical adjustment to recover it has been published on diesel forums since the late 1990s. Injection shops have been advancing timing on customer trucks for 30 years. This is not a secret in the Cummins community. It is standard knowledge passed from one owner to the next on every diesel forum that exists. What it has never been is easy to find in a format that treats the owner like they deserve to know what is inside their own engine. The 12-valve Cummins has a reputation that nothing else in diesel truck history quite matches. 500,000 miles on a stock bottom end is documented regularly. 700 rear-wheel horsepower on a factory block is a documented outcome with the right pump and injectors. The engine that came in a budget-tier Dodge Ram has outlasted the entire diesel performance industry's attempts to improve on its basic architecture. That reputation was built on what the engine was capable of, not on what the EPA allowed Bosch to deliver. 12 degrees, 215 horsepower, governed at 2,700 RPM from the factory. An engine that can run to 700 rear-wheel horsepower, shipped to owners running 6-cylinder fuel economy because a 12-degree timing pin and a governor spring. Said so. The pin comes out in an afternoon. It always did.